Okay, factoring in molarity. Molarity is the moles of a solute per liter of solution, and it's defined as the moles of solute per volume, or liters of a solution. So molarity is equals the mole of solute over a liter of solution. Okay, and you can see a lovely little diagram over here. For example, a 1 molar solution of sodium chloride is defined as the moles, moles over the solute of the solute over the liter of the solution equals 1 mole of sodium chloride in a 1 liter solution. Right, so how do we calculate these? Well, let's figure out what is the molarity of 0.5 liters of sodium hydroxide if it contains 6 grams of sodium hydroxide. Okay, so solution is step 1, we're going to state the given and the needed. We are given 6 grams of sodium hydroxide solute and 0.5 liters of sodium hydroxide solution. We need the molarity. So 1 mole of sodium hydroxide is 40 grams sodium hydroxide. So 1 mole of sodium hydroxide over 40 grams of sodium hydroxide is the same thing as 40 over 1. So let's figure this out. We have 6, okay, and then we have 1 over 40. Those cancel each other out. And then the times 0.150 moles of sodium hydroxide. Okay, so let's write the concentration expression, and then substitute the solute in solution quantities. Okay, and that ends up giving you 0.3 moles of sodium hydroxide. All right, so let's try this again. So what is the molarity of 0.225 liters potassium nitrate containing 34.8 grams of KNO3? Okay, pause me and come back. This would be, again, let's state the given and the needed. So we are given this and we need this. So let's set it up, okay, and then write the concentration expression. Substitute the solute and solutions quantities, and we're going to end up giving you the answer is B, which would be 1.53 moles of KNO3. Okay, so then using molarity as a conversion factor. The units of molarity are used as conversion factors in calculations with the solution. Okay, so we have molarity and the equality. So written as conversion factors, you can see that 3.5 moles of hydrochloric acid over 1 liter solution, and therefore a 1 liter solution would be the same, so vice versa. Here's your handy dandy little table of conversion factors. Okay, so the percent concentration means this, and the conversion factors would be written out here. So let's use these to use the concentration as a conversion factor. So our little table of doing this is step 1, we're going to state the given and needed. Step 2, we're going to write the plan to calculate the mass or the volume. Step 3, we're going to write the equalities and conversion factors. Step 4, we're going to set up the problem to calculate the mass or volume. All right, so let's try this. So how many grams of NaOH are needed to prepare 75 grams of a 14% solution, NaOH solution? Okay, pause me and come back. So we're going to state the needed, or the given and the needed. We are given 75 grams of a 14% solution, and we need the grams of sodium hydroxide. So let's write the plan to calculate this. And there it is. So step 3, let's write the equalities and conversion factors. Okay, here you go. Step 4, set out the problem to calculate the mass or the volume. Okay, and you end up getting 75 gram solution times 14 over 100 equals 10.5 grams of sodium hydroxide. So the answer is A. All right, so let's try this again. How many milliliters of a 7.5% ethanol solution can be prepared from 2.5 milliliters of ethanol? Pause me and come back. So given this, we need milliliters of ethanol solution. So let's write a plan to calculate the mass or volume, okay? And let's set this up and write the equalities and conversion factors, and then set up the problem, okay? So that we can calculate the mass or volume. So then we end up getting the answer is C, 39.1 milliliters. Okay, let's try this again. How many grams of AlCl3 are needed to prepare 125 milliliters of a 0.150 molar solution? Pause and come back. Right, so we were given this and we need the grams. So we're going to write a plan and then plug in those numbers. Okay, and then our solution is answer C, 2.5 grams of aluminum chloride. Right, great job.